All right, welcome to The Explainer. Today we're going to break down a really big leap in artificial intelligence. It's called DETRPose, and it's completely changing the game for how computers see and, really understand human movement.
So have you ever really thought about how a computer can watch a crowd of people and actually make sense of what everyone's doing? Well, it all boils down to this super complex task called pose estimation. And believe me, this isn't just a neat party trick. It's the core tech behind everything from, say, advanced sports analytics and immersive VR, all the way to smarter, safer, autonomous robots.
Okay, so to really get why this new system is such a big deal, we've got to first dig into the core problem here. A problem that has honestly been a huge headache for developers for years. We're not just talking about, finding a single person in a picture. No. This is about being able to map out the entire skeleton, the joints, the limbs, the facial features for every single person in an image, all at the same time. Think about a busy street or a packed stadium. Trying to track all of that movement at once, that is an incredibly tough computer vision challenge. And for the longest time, this whole field was just stuck. Developers were facing this massive trade-off, a real dilemma that put a hard limit on what you could actually do in real time. You see, you basically had two choices, and neither was perfect. On one hand, you had these top-down methods. They were super accurate, but, and this is a big but, they got slower and slower for every single person you added to the scene. So for real-time video, pretty much useless. Then, on the other hand, you had bottom-up methods. These were fast, for sure, but they weren't very precise. They'd find all the elbows and knees first and then try to piece them together into skeletons, which, as you can imagine, could get messy. So yeah, you could have accuracy or you could have speed. Getting both? That was the dream. The holy grail, really. So you might be thinking, well, what about those super powerful AI models, the transformers? And that's a great question. Their architecture is fantastic for getting things right, for accuracy. But they were always seen as these, lumbering giants. The big problem, the real bottleneck, was a part of the model called the decoder. That's the bit that actually puts the final pose together. And it was just so slow, way too slow for anything happening in real time. And this right here is where our challenger DETRPose comes onto the scene. And it's here to basically shatter that old trade-off. What makes DETRPose so special is that it's the first model of its kind that manages to take all the power and all the accuracy of a transformer and make it work for multi-person pose estimation, or MPPE, in real time. It's finally getting that top-of-the-line architecture to run at the speed we need. So the big question is, how did they pull this off? Well, the secret sauce, the real weapon here, is this incredibly clever new way of training the model. It completely changes how the AI learns to see poses. The researchers made a few important tweaks here and there to the standard transformer setup, things like an auxiliary layer and a new loss function. But the main event, the innovation that really makes all the difference, is this new training technique they developed called pose denoising. And this approach is, honestly, fascinating. Think about it like this. Instead of just showing the AI the perfect spot for someone's elbow or knee, the researchers did something different. They also showed it a bunch of noisy data, so points that were just a little bit off, and even some that were way, way off target. This whole process uses what they call positive and negative queries. The positive ones are those near misses, the points that are really close to the right answer. The model learns to pull those in. The negative ones are the points that are far away. The model learns to push those out. So what's the goal here? It forces the model to learn not just where a joint is, but just as importantly, where it isn't. And that little trick dramatically speeds up how fast it learns and makes it way, way smarter.
All right, so that's the theory, but let's get to the main event. How does this new kid on the block actually stack up against the competition? Let's look at the numbers.
And this is where it gets really interesting. That new denoising trick, it doesn't just make the model more accurate, it makes it learn incredibly fast. I mean, look at this. A previous state-of-the-art model needed something like 800 training cycles, or epochs, on a really tough dataset. DETRPose, it only needed 80. That's a 10 times faster training time. For anyone developing this stuff, that is a massive, massive deal. And when it comes to accuracy, well, the results really do speak for themselves. On the industry standard COCO benchmark, the large version of DETRPose goes toe-to-toe with the leading competitor, RTMolay. And as you can see, it leaves older models in the dust. And the crucial part? It's hitting this top-tier accuracy without that old speed penalty. And if you look at the whole picture, it gets even better. DETRPose delivers that best-in-class accuracy, while actually being a leaner, more efficient model. It uses way fewer parameters. You can think of that as kind of like the engine size than its main rival. And it's still running at an incredible speed. We're talking about just over 5 milliseconds here. That's real-time performance. Okay, so let's zoom out a bit. What does a breakthrough like this actually mean for the future? For the kind of tech that's going to interact with us in our daily lives? Here's the big takeaway. DETRPose proves that transformers, the most powerful AI models we have, are now officially ready for prime time for real-time pose estimation. It finally smashes that old speed versus accuracy problem to pieces. And what that does is it throws the door wide open for a whole new generation of complex, real-time interactions between us and computers. We're talking advanced VR, safer autonomous systems, and way smarter analytics. So this isn't just some paper sitting in a lab. It's not just an academic win. This is a foundational building block for the next wave of intelligent apps. It's the key to making VR more immersive, self-driving cars safer, and sports analytics even smarter. Which all leads to one final, really important question. Now that computers can finally read our movements with both lightning speed and incredible precision, what's next?